All right, so the last type of graph that we'll cover in Chapter 2 is called a stem and leaf display. So what this graph or what this chart does, it's actually one of a lot of different techniques of studying data that's called exploratory data analysis, or EDA for short. So again, it's one of the more useful ways to study data in a field. What EDA techniques usually do is they're particularly useful for detecting patterns and extreme data values like outliers are. So they're designed to help us explore a data set in case we come up with questions that don't come up right away, or we want to pursue leads in many different directions. Think of it like an explorer, right? So just like an explorer, EDA techniques have a general idea of destination, right? But we generally know where we're going, but it still leaves room for the unexpected, right? And when the unexpected happens, then we need to assess the situation quickly and clearly. And then, of course, an explorer maps out the relationships of landscape features. So EDA techniques also help us show relationships between data here. So some key components of EDA techniques include rapid implementation, visual displays, data simplification, and analysis with limited or none at all influence by extreme value. So limited influence, if any at all. All of these components can be found in a stem and leaf display. So what is a stem and leaf display? A stem and leaf display is a method of exploratory data analysis that is used to rank, order, and arrange data into groups. So again, that's two things that we're going to be doing while making these displays. We're going to put things in order, and we're going to arrange the data into groups. So a good thing about a stem and leaf display that we don't get from a histogram or a frequency distribution. So histograms provide useful organization and summary of data, but when we do histograms, we often lose most of these specific data values, and we only get just the broader sense of it. But with a stem and leaf plot or a stem and leaf display, we organize and group the data just like a histogram would, but in the design of the stem and leaf display, we can actually recover the original data if we need to. Okay, so how do we create a stem and leaf display? All right, we'll use this as an example. Many airline passengers seem weighted down by their carry-on luggage. Just how much weight are they carrying? The carry-on luggage weights in pounds for a random sample of 40 passengers returning from a vacation to Hawaii were recorded in the table below. So again, notice that this table has a title, weights of carry-on luggage in pounds. Okay, so it's got a title, and it's got the unit of measurement being specified. All right, so here's what we're going to do. To make a stem and leaf display, we break the digits of each data value into two parts. The left group of digits is called the stem. The remaining group of digits on the right is called the leaf. So the leftmost part of the digit is called the stem. The rightmost part of the data is called the leaf. Now the good thing about this is we're free to choose the number of digits to be included in the stem. So think of the stem as like the independent value and the leaf as the dependent value, right? The digits on the leaf depend upon what digits are there on the stem. So we can choose how many digits that we want in the stem, and everything else goes to the leaf. Okay. So the weights in this example consist of two-digit numbers. So for a two-digit number, obviously the left digit, the tens digit, is going to be on the left. That's going to be our stem, and the ones digit is going to be our leaf. Okay. So in this case, the tens digit will form the stems. The units digit will form the leaves. All right. For example, if a luggage weighs 12 pounds, then 1 is the stem and 2 is the leaf. So again, for 18, what would be the stem and what would be the leaf? Again, left digit is the stem, so 1 would be the stem, and 8 would be the leaf. And because the stem for these two matches, these two leaves would be on the same stem. Okay. So first thing we want to do is we want to divide the digits of. So once we divided the digits into our leaf and stems, We align all the stems in a vertical column from smallest to largest, like you see here. So here's where where you have your ones digits, or your tens digits right here. Then we want to draw a vertical line to the right to separate the stem from the leaves. Then we want to place all the leaves with the same stem in the same row as the stem. For example, the 12 and the 18 go on the same stem, right? They all go on the same stem. Now, once we get all of our leaves, in a row, all right, then we can start ordering them from smallest to greatest. So, for example, I'm going to do this right here. Yeah, here we go. So, for example, here's my stem, 0, 1, 2, 3, 4, 5. There's my stem. I'm going to put each data point in. Put each data point in numerical order. So 0 and 3. For this one, I have 2 2s, a 7, 3 8s, and a 9. 1, 2, 3, 9. Here I have, let's see, 3 1s. 1, 2, 3. I have a 2. Then I have 2 6s. 1, 2. I have 2 7s. Then I have an 8 and 2 9s. 8, 9, 9. And you want to make sure that you're accounting for all your data here. All right, for 3, we'll start out with 0, then 2 1s. Let's see, 1, 2, 3, 4 2s. 1, 2, 3, 4. Then 1, 2 3s. Let's see, I don't see any 4s, but I see 2 5s. Then I see a 6. And I see 2 8s. 1, 2. For the 4, and again, this all comes from this data right here. This data gets put onto here, right? And then it gets reordered here. For the 4, I have a 1, 2, 3, 5, and 7, and then 5 gets the 1. Okay. Again, let's go back and just to recap, right? So all of this data that's on this side, all this data that's on here, right? We have our tens digit, 0, 1, 2, 3, 4, 5. For the 0, that means any number from 0 to 9 gets put here. So that's why I have 0 and 3. Where the stem is 1, that's all numbers from 10 to 19 go in here. Here, 20 to 29, 30 to 39, 40 to 49, and then, of course, 50 to 59. Once that data gets all put together, think of it as a tally, right? Because remember when we did frequency distribution, we tallied them up, then we counted up the tallies. Think of this as a tally, right? And then once we have all of our tallies, then we put it into a particular order. So again, let me clear this out so y'all can see better. So again, there's your thing in order. So let's ask some questions to help us analyze here. So how many bags weigh 27 pounds? Well, let's look at it. So 2 is the stem, and I'm looking for leaves of 7. So here's 2. There's 2 7s. So that means 2 bags weigh 27 pounds. How many weigh 32 pounds? Again, so this time our stem is 3. We're looking for leaves of 2. 1, 2, 3, 4. 4 bags weigh 32 pounds. Most of the weights were in what range? Well, look, where are the most leaves at? Here. So most of the weights were about 30 to 39 pounds, right? I mean, if you wanted to include this too, you could say that, well, between 20 and 39 pounds, if you're going much larger. But if you're looking for a specific stem, the 3 stem has the most weights in it. How many bags were less than 20 pounds? So anything below, or in this case, anything that's in the 0 or 1 stem. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 bags weighed less than 20 pounds. How many bags were over 40 pounds? Well, 41, 42, 43, 45, 47, and 51. That's 6 bags. 6 bags were over 40 pounds. Okay. Now, once we divide the digits into our stems and leaves, we align the stems. We draw a vertical line to the right of the stems. We put all of our leaves in the proper stem, and we arrange the leaves in order from smallest to greatest. The very last step is to indicate what your scale is. How am I supposed to be able to read things on a stem and leaf chart? So this is usually done by indicating the value represented by one stem and one leaf. So use an example. Use an example from your stem and leaf plot. For example, if on a three stem and a 2 leaf, that represents 32 pounds. That's an example indicating what the scale is. Okay. So question is, what exactly do stem and leaf displays tell us? Well, they tell us 3 things. They show us all the data in order from smallest to largest. They help us spot extreme values or clusters of data values, and they display the shape of the data distribution, kind of like a histogram does. But again, unlike a histogram, it consists of the actual data itself, as opposed to an analysis and interpretation of the data. Okay, so even if we have our stem and leaf plots, we can still reconstruct our original data from that.